Good morning. Good morning to everyone. I'm Spot on Weather Meteorologist Matthew Euler. Welcome to this new video. And I've been sitting here thinking about the upcoming winter forecast, and there's a lot of things that must be taken into consideration. And I'm going to kind of break a few of those considerations down in today's video. This is part one of my winter season considerations video series. I will get around to doing part two, and we'll include a few more things outside of today's video. So the objective of today's video is to discuss winter seasonal forecast considerations for the upcoming 25-26 winter season. And we have to begin with a talk on the ENSO, the El Nino Southern Oscillation. So you may have seen a lot of different things going around social media right now, but I wanted to let everyone know that we are expected to see La Nina to start the winter, but there's going to be a transition to more ENSO neutral conditions in January. All right, so this La Nina is not going to last the entire winter season. La Nina will also be weak, which opens the door for other teleconnections to be more influential in shaping our weather pattern. And due to its brevity and weaker state, we are not anticipating or expecting a slam dunk La Nina weather pattern winter from start to finish. I know what you typically see during a La Nina weather pattern in the winter. You typically see colder and wetter conditions along the northern U.S. You see drier and warmer or milder conditions across the deep south, the Gulf Coast, up towards the mid-Atlantic. But we really don't see the La Nina persisting the entire winter, and I'll show you why here in a minute. Now, the stronger the La Nina, the more reliable we could see the forecast being for the La Nina type impacts to the United States. But again, we're looking at a weak La Nina, a shorter duration La Nina, so we're not expecting those longer term, those typical La Nina maps that you see circulated around. We do see various La Nina strengths as well. When we think about La Nina strengths, we have to think about the different results that those different strengths produce. The temperature and precip anomalies across the United States during the winter season are going to vary. And one other thing to mention is there are no two La Ninas ever exactly alike. There's going to be some smaller changes and twists and turns along the way of the winter forecast with La Ninas in general. Just because La Nina behaves this way one winter does not mean it's going to behave the same exact way the next La Nina winter. We look at the strengths in the La Nina. Okay, now this is important to look at. I'm showing you, this is courtesy of NOAAclimate.gov. These are the December through February months, so the meteorological winter months. These are the temperature anomalies here on the left during strong, moderate, and weak La Ninas going back to 1950. Now, this map here on the left doesn't necessarily show you some of the later La Nina winters, such as 2020, 21, 21, 22. 22, 23 is not on here, but generally it's a pretty decent sample data set here. We're going to start off here in the upper four panels here. You notice these four up at the very top here on the left-hand side. We saw a strong La Nina in the 1973-74 winter, the 88-89 winter, the 1990-2000 winter, the 1975-76 winter, and then we drop down to the second row. We also have strong La Ninas in the 07-08 winter, the 1949-1950 winter, as well as the 1998-99 winter. Okay, now those are the strong La Ninas of the data set here. Now look at the peach colorings and the blue colorings on these charts. The peach colors indicate above normal or milder than normal temperatures. The blue colors below normal or cooler than average temperatures. So for stronger La Ninas, you notice in general, we have a milder southern U.S. and mid-Atlantic. We saw that in 73, 74. We saw that a little bit weaker, but still there from the signal from 1988 and 89 winter. well, pretty much the entire United States was above normal for 1999-2000 winter season during that strong La Nina. 75-76, milder temperatures in the mid-Atlantic. 2007-08, again milder from the southern Gulf Coast area up to the mid-Atlantic. And then also the 1949-50 winter, well above normal from the Gulf Coast up the eastern seaboard. And then we see right here the 1998-99 winter, milder than normal across much of the United States. Now that is a stronger signal, right? When we talk about a stronger La Nina, we'd expect more influence from that ENSO state, right? From the La Nina itself on the temperature anomalies. Now we look at the moderate La Ninas, 1970-71, 2010-11, 1955-56, 84-85. Those are the four we'll look at. So 1970-71, now that we're moderate La Nina, we have milder temperatures in Texas into Louisiana, colder than normal where you'd expect it for La Nina across the northern U.S., the northern plains, Minnesota, Wisconsin, into far northern New England. 2010-11 winter, an oddity, right? Look at this. A moderate La Nina, but colder than normal from the northern plains to the east coast down to Florida. That is not your normal La Nina pattern there, is it? The 1955-56 winter, we had a more typical La Nina looking pattern during that moderate La Nina across the northern U.S., below normal, into Montana, the Dakotas, slightly below normal across New England, and milder than normal across the deep south. 84-85 featured a moderate La Nina, and we had below normal temperatures across generally where we'd expect it, across the Pacific Northwest and the northern plains. So now let's examine the weak La Nina winters, 95-96. Well, look at this. 95-96, we saw blue coloring from the northern plains to the east coast. Look at that. Mid-Atlantic was actually slightly below normal in the 95-96 winter, despite it being a La Nina, because it was a weak La Nina. We see above normal temperatures across the southwestern U.S. 2005-2006 winter season, weak La Nina, it was much milder. So it's a different outcome, right? For the 05-06 weak La Nina winter compared to the 95-96 weak La Nina winter. 08-09, more typical La Nina look. Northern plains, upper Midwest, below normal temperatures. Above normal temperatures from New Mexico, Texas, along the Gulf Coast up to the mid-Atlantic. 2011-2012 La Nina winter season. This was a weak La Nina as well. Well above normal temperatures up in the Minnesota and the northern plains. That's not normal for La Nina. And then well above normal across all the eastern U.S. The 1954-55 weak La Nina winter. Below normal across the western U.S., slightly below normal across the eastern U.S. The 1971-72 weak La Nina winter. Well below normal temperatures, Montana, the Dakotas, into Minnesota and Wisconsin, and well above normal temperatures along the Gulf Coast, Florida, up to the Mid-Atlantic. The 2001 winter season, below normal for much of the northern plains, Midwest, that's where the coldest temperature anomalies were, and slightly below normal across the eastern U.S. 1964-65 weak La Nina winter, well below normal temperatures across Montana, North Dakota, parts of Minnesota, and then near normal to slightly above average of the southeastern U.S. And then 83-84, we're talking about the weak La Nina winter then, well below normal temperatures across the western U.S. down into the southern plains. And then in 74-75 weak La Nina winter here on the bottom left, above normal in the peach color here from Florida all the way up towards New England, with below normal temperatures across the southwestern U.S. and to the northern plains. And this is a breakdown on the right of weak, moderate, and strong La Nina winters. Okay, and most recently we've seen La Nina winters. There were weak La Nina winters in 2016-17. 2017-18 was a weak La Nina winter. 22-23 weak La Nina winter, and then you see other more recent moderate La Nina 2021 and 21-22 winter seasons. All right. And I will say, we had a strong La Nina there in 2010-11, which is not indicated over here on the left, but that 2010-11 winter season was below normal for the East. So bottom line here is the strengths of the La Ninas must be taken into account to really determine what kind of temperature anomalies you're going to see across the United States. We look at the forecast now on the left. This is the NOAA Climate Prediction Center ENSO probability forecast in percentages here. So this is the percent chance on the vertical axis on the left from 0 to 100%. Blue coloring, the blue vertical bars indicate La Nina. The gray bars indicate ENSO neutral. I won't even get into the discussion on El Nino for the winter because it's not happening this winter. But in general, what you see is September, October, November, just below 80% chance of La Nina conditions, compared to only a little over 20% chance for ENSO neutral. October, November, December, just about 77% chance of La Nina versus only a 22% chance for ENSO neutral. The months of November, December, January, we're still above 70% probability for La Nina, and we're up to about a 30% chance or probability for ENSO neutral. December, January, and February, we see La Nina, 55% chance, vice 41, 42% chance for ENSO neutral. But then January, February, and March. Now, this is my turning point here that I mentioned, where we transition from La Nina with only a 40% chance versus ENSO neutral, which is now up to a 55% chance. So I really believe this, that we're going to see a transition from weak La Nina conditions into ENSO neutral conditions around January. We look over here on the right-hand side. These are the IRI. This is the temperature forecast as far as the Nino 3.4 region. Where are the statistical and dynamical models showing the water temperature anomalies to be in that Nino 3.4 region? Now, unfortunately, this is still September, and the new IRI plumes are coming out today. I just don't know at what time. So I'm cutting the video this morning. I'm sure I'll have an update on the latest IRI plumes in a bit, maybe later this afternoon. But in general, from last month's plots, you clearly see that both the statistical and dynamical models are showing a minus 0.5 to minus 0.7 degrees Celsius temperature anomalies there for water temperatures across that Nino 3.4 region. Okay, so generally pay attention to this, minus 0.5 to minus 0.7. Both of these models are showing it, and then that transition towards ENSO neutral conditions. What about the quasi-biennial oscillation, the QBO? Now, it's expected to be in an easterly descending phase this winter. It's another winter forecast consideration, right? Because the easterly QBO tends to favor a weakened stratospheric polar vortex, and it tilts the odds for a negative phase of the NAO. Now, look, just because research has indicated this, and maybe this easterly QBO favors a weakened stratospheric polar vortex the majority of the time. Any kind of discussion of the atmosphere, you're going to have some sort of variability. In other words, the majority may indicate this, but there's been winters that easterly QBO, maybe it didn't favor a weakened stratospheric polar vortex. Maybe there's some outlier winters here where you had easterly QBO and a stronger stratospheric polar vortex. So again, this is just tilting the odds. This is not etched in stone when I talk about the easterly QBO, but it's a general good rule of thumb to use. Now, Holton and Tan, two researchers in 1980, discovered this relationship describing how the QBO in the tropical stratosphere influences the polar vortex in the northern hemisphere. So this relationship that they discovered in their research explains how the QBO tends to alter this propagation or movement of atmospheric waves from the tropics into the middle latitudes as well as the higher latitudes. And this change in atmospheric wave propagation between the stratosphere and troposphere occurs. And this helps to set up more favorable upper air patterns for disrupting the stratospheric polar vortex. If we look at another bit of information I find interesting, and this is from Weather Risk, graphic courtesy of Weather Risk, this is his research, we see easterly QBO plus a weak La Nina here. So winters with a weak La Nina and a QBO that was negative or easterly based in November. And if that QBO stayed negative or easterly based all winter into March with a weak La Nina, look at the temperature anomalies here. Okay, we see a warmer than normal temperatures out in the western U.S., the yellows and oranges. We see colder than normal, generally east of the Rockies to the East Coast. Now, notice the deeper blue colors, that indicates the area with the strongest cold temperature anomalies. So Illinois, Indiana, Ohio, right in that area, deeper blues occur up to 4 degrees Fahrenheit below normal for those winters. And these are some of the winters: 62, 63, 67, 68, 81, 82, 83, 84, 2001, 14, 15. So you see a lot of people talking about potential analog of the 14, 15 winter season. So that's why. But in general, weak La Nina again. And see how weak is capitalized there? Okay, that's an emphasis point right there. If we look at the North Atlantic Oscillation, since we talked about the easterly QBO favoring, in general, a negative phase of the NAO, we're already seeing the negative phase of the NAO for a lot of October right now. And just showing you some examples. Now, these images are courtesy of Penn State University. Positive phase of the NAO, what do you have happening there? You get anomalously low 500 millibar heights and troughing here, generally between Greenland and Iceland. Okay, so across the North Atlantic, you got below normal heights and troughing. So anomalously low heights there. We have anomalously higher than normal heights, generally just to the west of Spain. So when you have a stronger height gradient, so let's say this is very strong higher heights here, west of Portugal and Spain, anomalously lower than normal heights just to the west of Iceland, and you're going to get a stronger flowing jet stream from west to east across the North Atlantic with a positive phase, the NAO. The greater this pressure or height difference, the stronger the jet stream is going to blow in between these two systems. With a negative phase, the NAO, what happens is we get a wavier jet stream. The wind speeds within the jet stream slow down. We get a strong blocking high now, just off the southeast coast of Greenland. We get relatively weak subtropical ridge or subtropical high there to the west of Portugal. And then we get a relatively weak 500 millibar low to the northwest of the British Isles. So you notice with the blocking high, we have a very strong upper level ridge in place. The jet stream has to go up and over the top of the ridge, as well as these weak disturbances, okay? Now, not only do we have a difference between a positive and negative phase of the NAO, we have to talk about the difference between an east versus west-based negative NAO. Look on the left here. This is a east-based negative NAO. This is courtesy of the North Carolina Climate Office, by the way, these graphics. They're the ones who came up with this. I'm just showing you what they came up with. So with a east-based negative NAO here on the left, the oranges represent anomalously high heights, the purples and blues anomalously low heights. So think strong upper level ridges with the orange colors, and the purple colors and blues, think of troughs, upper level troughs. So you notice with a negative or east-based negative NAO here on the left, look at the orange colorings located across the North Atlantic. Highest upper level heights are generally east of Greenland with a east-based negative NAO. The coldest air is going to be generally located in the plains and the Midwestern U.S., further to the west with that scenario. Now, if you get a west-based negative NAO over here on the right, you see the anomalously, these orange colors here, the anomalously higher than normal upper level heights are located west of Greenland. So in this case, you notice the negative NAO height anomalies are located closer to the North American continent, and you're going to get a storm track in the coldest temperatures further to the east across the eastern U.S. So this is a favorable storm track situation with a west-based negative NAO. So not only do you have to look and study the phases of the NAO and look where these pressure patterns, look to determine where the pressure patterns are located, but you also need to look at the east-based negative NAO versus the west-based negative NAO. We look at reloading type winter pattern types here, reloading winter pattern types. You see a negative NAO here on the left. Now, the red lines indicate above normal upper level heights associated with ridges. So we see a ridging up into southern Greenland here on the left. This is a negative NAO loading pattern. So higher than normal heights across Greenland and the North Atlantic. And we get below normal heights beneath it across these blue dashed lines represent below normal heights and troughing generally beneath it over the eastern U.S., extending across the North Atlantic into northwestern Europe. We also have the positive PNA loading pattern here on the right, which shows very strong Aleutian low But the Aleutian Low is parked back towards basically between Russia and the Aleutian Islands. And so the position of this Aleutian Low is so critical, the location of it. What happens is this low really gets cranked up, this Aleutian Low, and you're going to get anomalously higher heights building east of the Aleutian Low across Western Canada. And beneath those upper level ridging across Western Canada, you get below normal heights in the blue dash lines across the southern U.S. up towards the mid-Atlantic. But again, the strength of the Aleutian Low as well as its position really do matter as far as where this upper level ridging sets up downstream. Now, I'm going to end today's video talking about what one potential winter season analog I kind of like right now. I'm still kind of liking it. Doesn't mean it's right, but I really see a lot of similarities right now to the 2001 winter season. So let me share the reasons why I see similarities to this upcoming winter forecast and this particular winter. Let's examine the MJO, okay, over here on the left. This is the MJO from October 2000 to late December 2000 on the left. When you see the red line indicates the MJO in October, and it's generally moving into phases 3, 4, 5, and 6. That's what happened in October of 2000. Now the blue line, the green line is November. So in November, the MJO moved around and rotated into phase 7, phase 8, phase 1, and back into the inner circle, back out into phase 2, and around to phase 3 and 4. And then the blue line represents December. The MJO started in phase 5, went into 6, 7, back into 8, and then back into the small inner circle here. All right. I'm seeing similarities, a little bit later in the month, yes, but I'm seeing some similarities in the MJO right now. If you look at the MJO latest forecast, I don't have it up here, unfortunately. I should have snipped it and showed it compared side by side with this on the left, this graphic on the left with the MJO. But right now, the MJO is moving up towards 3, 4, 5. I'm seeing a lot of the MJO forecast models showing it in this direction, similar to October of 2000. So I find that kind of interesting in its similarities. Over on the right-hand side, this was the MJO for January 2001 to March 2001 from that winter. And the red line is for January. So we came out of the null inner circle here in early January out into phases 2 and 3, kind of wrapped back around, went into phases 2 and 3 more significantly in strength. And then the green line represents February. So February, we started in phase 3, went to phase 4, 5, 6, 7. Now, February got milder, and I'll show you the temp anomalies here in a minute. But it's no surprise February got mild to the east because we went into the milder MJO phases over here in 5 and 6. Now, the blue coloring indicates the March MJO from 2001, showing it starting in phase 7, briefly going into phase 8, coming back into this inner small circle. Now, let's look at the other teleconnections here. This was the NAO index from December 1st all the way out to March 31st, where you see the blue bars indicates a negative phase of the NAO. So you notice for the first week of December of 2000, we saw a negative phase of the NAO. It's pretty strongly negative. We saw a rebound to positive with these red bars, positive phase of the NAO, right prior to mid-December, then back strongly negative for the end of December for the NAO. Briefly positive, back down negative, and then positive again into late January. And it really went strongly positive for the NAO in the middle February timeframe and late February timeframe. We look at the AO index. Wow, the Arctic oscillation was strongly negative right out of the get-go to start meteorological winter. The first couple of weeks of December, negative. Look how strongly negative the AO became in late December, right before New Year's Eve. I mean, my goodness. All the way down almost to -5 on the AO. And it remained strongly negative really all the way up through mid-January of 2001 before rebounding to slightly positive. And then dipped right back down to negative, the AO there beyond the 30th of January and into parts of early February before becoming more strongly positive again, AO, in mid-February, then dropping strongly negative again in late February. So a lot of negative AO in the winter of 2001. And this makes sense when I show you the temp anomalies for December. It was a very, very cold month overall. And one other thing I want to mention about the AO, when it's strongly negative like this, you typically see a weaker stratospheric polar vortex. When the AO is more strongly positive, we see a strengthening or stronger stratospheric polar vortex. We look at the PNA, the Pacific North American Index, for the winter of 2001. Positive PNA. Look how consistently positive the PNA is with these red vertical bars, all the way to the end of January. That favored eastern U.S. cold. So a very, predominantly negative AO winter of 2001, and then also a predominantly positive PNA in 2001 winter season. We look at the 500 millibar height anomalies here on the left. This is December of 2000. Blue coloring in green indicates troughs. Orange coloring indicates ridges. So we see some troughing across the eastern United States, the eastern Great Lakes, Ohio Valley, right onto the mid-Atlantic for December of 2000. There was a very strong Aleutian low, but look at the position of it again. It's further to the west. And that allowed these heights to build out east of this deepening or very strong Aleutian low and troughing. You saw the upper level heights rise across just north of Alaska, across the Arctic. We have anomalously higher than normal heights across Alaska, the Yukon, Northwest Territories, down to Western Canada and the Western U.S. And we saw the below normal anomalies, height anomalies there in the troughing in the east. We also saw a fairly strong North Atlantic low pressure system. We saw above normal heights across Greenland. So this December 2000 looked at a positive PNA plus a negative AO with higher than normal upper level heights across the Arctic. That indicated a colder eastern U.S. Over here in the middle, January 2001, we still see that stronger Aleutian low, but it's now shifted further east. And when it shifted further east, the highest than normal height anomalies also shifted further east into central Canada. We did see some below normal heights there to the west of Greenland, and we see some above normal heights across northern and northwestern Europe. And then over here on the right, February 2001, we have ridging that's back in place across Alaska, but then we have a shorter wavelength where we get troughing off the California coast, and then ridging again downstream from that, east of the Mississippi River. Southeastern ridge looks like it's locked in place here in February 2001 across the mid-Atlantic and southeast with mild temperatures to end the winter. Let's break these months down, the winter months now, December 2000, and I'll go through January 01 as well as February 01. But December 2000 temp anomalies, look how below normal things were. Very, very cold month across areas east of the Rocky Mountains. Look at this magenta purplish color here. Minnesota, Iowa, northern Missouri, Illinois were running 14 to 16 degrees Fahrenheit below normal. And you see the purple coloring goes all the way to the Ohio River. We're talking anywhere above 11 degrees Fahrenheit below normal, and the next shade of purple from Ohio into western Kentucky, southern Illinois, southern Missouri, eastern Kansas, eastern Nebraska, and the Dakotas. And then the green coloring indicating temperature anomalies running from 6 to 7 degrees below normal from southeastern Virginia up through Maine. We also saw below normal temperatures along the Gulf. Now keep in mind, this was a weak La Nina winter, right? This shouldn't happen in a La Nina winter, right? No, that shouldn't happen. Where it's colder than normal east, all the way down the Gulf. No, this should be milder down here. This should be milder to the mid-Atlantic. And we saw the mildest temperatures in this peach color across the desert Southwest back towards California in December of 2000. January 01 temp anomalies. Look at this. Well above normal temperatures across the northern plains. That should not be happening in a La Nina winter, folks. This should be below normal up here, not above normal. And we see below normal temperatures continuing across the deep south up towards the mid-Atlantic. I mean, look at this. Mississippi, Louisiana, Florida Panhandle running 5 to 6 degrees Fahrenheit below normal in January 2001. Now, things have cooled down in January 2001 out in the desert Southwest area into California by this point. And then February, it flipped. February, this started looking more like a La Nina winter now. So you notice Minnesota, the Dakotas, Montana, Pacific Northwest below normal. This is where you're going to see NOAA put the below normal temperatures for the winter season outlook during La Nina. All right. This is generally where you're going to see the warmer and drier conditions as well across the mid-Atlantic and the southeastern U.S. and the Gulf Coast. So things flipped around in this weak La Nina winter there in February of 2001. What does this tell us? Even though it's a La Nina winter, all right, even though this was a La Nina winter, the atmosphere did not respond the same way each month of the winter. December, no, well below normal in the east. January still did not respond like a typical La Nina. It took all the way to February for the atmosphere to make it look like a more of a La Nina type pattern. Here were the actual, look at this. On the left, this was the December to February. This was 2001 winter temperature anomalies on the left. Look at this. Not much of the U.S. was milder than normal, was it? And this was a La Nina winter. A weak La Nina winter, everybody. And look, below normal temperatures. And the coldest anomalies were across Minnesota, eastern Dakota, South Dakota there, eastern Nebraska, Kansas, Missouri, Iowa, and Illinois. Look at this. And it was still running anywhere from 2 to 3 degrees Fahrenheit below normal across the eastern U.S. That's not what you get in a La Nina winter. You look over here on the right, these were the precipitation anomalies. Now, this is what you would expect in a La Nina winter. Usually you get more of the above normal precip across the Ohio Valley. It will be in this location, Indiana and Ohio. But it was a little bit further back to the west that winter across Illinois, Iowa, Missouri, eastern and central Kansas to Oklahoma and Texas. Above normal precip in the lighter green colors. Well below normal, dry winter across the Pacific Northwest. That's not normal for the La Nina winter. So well dry, well below normal, dry across western Washington State, Oregon, and in Northern California. Now, this does make sense for La Nina winter, where you have drier than normal conditions across the mid-Atlantic, from Virginia down to the Carolinas, down at the Gulf Coast. Okay? So just wanted to show you the entire winter season now. Now, why do I think there's some similarities for the 2001 winter season to the upcoming 25-26 winter season? Well, if I just use a few factors here, if I'm using the below average temperatures for both the preceding August and September, and October has not been warm at all, I'm going to have to take a look now to see if I can go back in time and see, most likely we're looking at below normal August, September, and October for Hampton Roads. All right. So I may have to go take a look back at Mid-Atlantic as a whole here after October concludes. But here's the thing about the 2001 winter season. First of all, it had a La Nina. Now, look at these temperature anomalies in the Nino 3.4 region, the water temp anomalies. Started at minus 0.7 degrees Celsius and warmed to minus 0.5 degrees Celsius. Let's go back. Let's go back earlier in my video. Now, watch this. Hang on, we're going to get there. I got to find it. Nope, not that far. Okay, hang on. What are we looking at here? Look at this graphic by IRI here on the right. Look at the temperature anomaly forecast. This was from September now. I'm waiting to see the new one when it comes out later today. But 0.5 to 0.7 degree temperature anomalies in the Nino 3.4 region for those water temperatures. That's what's forecast for this winter. And it was exactly the same range of water temperature anomalies in Nino 3.4 in the 2001 winter season. I like that similarity. The easterly cubia was there in the 2001 winter season. We're seeing that right now. The negative pedia was in place. However, the one big difference, and of course this could be a big influencer on the weather pattern, right? Since the weather moves from west to east, the North Pacific Ocean water temperatures were cooler in the 2001 winter than they are today. So, I mean, this could be a big time game changer influencer on the weather pattern in this upcoming winter that may not necessarily match up with 2001. Now, a lot of times it's best to go with a blend of multiple winters. So, maybe we're looking at more of a blend between the 2001 and the 14-15 winter season, or a blend of the 17-18 winter season with that weak La Nina and this 2001 winter season. I wanted to make this video to show you, winter seasonal forecasting is one of the most difficult forecasts to come up with, because in the wintertime, We've got a lot of dynamical pieces in place across the northern hemisphere. We have a lot of fast-moving weather systems, and where do the upper level blocks set up really matters. How strong is the Aleutian low? What is the strengths and the positions of the Icelandic low and the Bermuda subtropical high pressure? I mean, these are all factors, and it's not easy forecast at all. So that wraps up my video today, part one. Um, my goal, and I have goals, is to work on part two this week. So hopefully I can crank that out by Friday. Um, Probably going to turn to teleconnections here, my next teleconnections discussion soon. So my focus is going to be diverted temporarily away from this. But I do want to do a part two, which kind of goes into other factors that we need to look at for the winter seasonal forecast. All right, that's all I got for now, everybody. Until next time, take care and God bless everyone.